Welcome back everyone. Today we are going to make some bromobenzene. For this, a really small amount of aluminium powder, 44 milliliters of benzene, which represents a small axis, 75.19 grams of elemental bromine, which is what's exactly contained in this bottle, some distilled water, and also some anhydrous calcium chloride are needed. Because we are working with bromine and bromine is very toxic, and because a lot of hydrogen bromide vapors will be generated, we are working with a gas mask, a gas trap will also be employed, and we are working in a very well ventilated area. Before we begin, I am going to explain the apparatus to you which we are going to use. The apparatus we use consists of this magnetic stirrer, beneath this 2-neck round bottom flask which has a stir bar in it. And we are using a water bath to cool down the reaction. Ice bath may not be necessary, but I don't know. I hope that this water bath is going to work. On top of the water bath and the round bottom flask, we have connected a 100 milliliter pressure equalization addition funnel through which we are going to add the bromine and also a reflux column to keep down the bromine and the bromobenzene vapors. Hydrogen bromide that will be produced will be led through this tube into this secondary flask, in which we have a pre-weighed amount of water, because we are not going to waste the hydrogen bromide that's produced, we are going to produce some hydrobromic acid. We then start off by adding a really small amount of aluminium powder to our reaction flask. The aluminium powder will react with the bromine to form some aluminium bromide, which is crucial for this reaction. 44 milliliters of dry benzene were then measured out and added to the round bottom flask. Because the bottle of bromine has been pre-weighed, we can simply dump the entire bottle of liquid bromine into the addition funnel. The magnetic stirrer was turned on and the bromine addition was started. The reaction that's taking place can be seen above. Benzene will react with bromine to form bromobenzene and hydrogen bromide. The reaction is known as the Friedel-Crafts alkylation. Aluminium bromide or every other Lewis acid act as the catalyst. The hydrogen bromide that was bubbled into the other flask eventually made all of those nice smoke rings. Hydrogen bromide dissolves really well in water, and therefore there should be nearly no hydrogen bromide leaving the flask. When the end of just the tube is submerged in the water, you have to make sure that no suckback occurs. Hydrogen bromide dissolves so well that it could easily flow all the way up this tube into our apparatus, ruining our reaction. An excess of benzene and a cooled reaction vessel is necessary. The bromine must also be added really slowly. If the reaction gets too hot, a lot of biphenyl may be created. This is because bromobenzene that was produced can also react with excess benzene to, also in the Friedel-Crafts alkylation, form biphenyl. When the hydrogen bromide evolution ceased, the addition funnel was removed and the reaction flask was placed into a heating mantle. Under reflux, the reaction flask was heated up for an hour to drive off all of the dissolved hydrogen bromide. Once it seemed like no more hydrogen bromide was leaving the flask, the reflux condenser was switched out for a distillation bridge. Bromobenzene has a boiling point of 156 degrees Celsius. Therefore, everything passing over below 145 degrees Celsius passing over was directly discarded. To speed up the distillation, we later on wrapped our flask and part of the distillation bridge in aluminium foil. There were still some hydrogen bromide vapors leaving the distillation apparatus. The flasks were switched out at some point in order to collect the fraction that we wanted. Afterwards, the flask was put aside and we continued the next day. The next day, we had to clean our product. There was still a lot of hydrogen bromide and other stuff dissolved into this. To get rid of any hydrogen bromide, the crude bromobenzene will be washed with some 5% sodium hydroxide solution. The sodium hydroxide solution was first transferred to a separatory funnel, followed by the bromobenzene. You can see that there's still a lot of hydrogen bromide smoke leaving the flask. The separatory funnel was shaken a few times and vented, and afterwards the bromobenzene layer, the upper layer, was allowed to separate. After separating, the bottom layer was disposed of. The bromobenzene was transferred to a storage bottle containing some calcium chloride for drying it. The storage bottle containing the calcium chloride was weighed in advance to determine the yield. The amounts of water in there should be negligible. And there you have it, bromobenzene. This video is also a great example of why you should use your drying agents accordingly, because the calcium chloride sort of turned into those really fine flakes which are now settling down, and I really have to get some molecular sieves for drying my solvents, because this is not acceptable and we will have to redistill our bromobenzene before I can even use this. As a side note, this was our gas scrubber. Its weight increased by 33.8 grams. Judging from the color, this solution contained approximately 0.5 grams of elemental bromine. If we leave the bromine that had dissolved aside, the solution should be approximately 24% hydrobromic acid. One could win back the bromine by simply adding hydrogen peroxide to turn the hydrobromic acid into more bromine, followed by distillation. In total, about 30.5 grams of bromobenzene were collected. This corresponds to a yield of about 37%. Because the amount was pretty small and I planned a large synthesis in the future, we will have to order a big amount of bromo or chlorobenzene. It was still fun to produce this chemical and we will definitely put it to use in some project. If you liked today's preparation, make sure to drop me one of these and consider subscribing to my channel for more chemistry content in the future. I wish all of you a nice day. Until next time. Bye.